How do planets form?
Planets form through a process known as planetary accretion, which occurs within protoplanetary disks. Here's a step-by-step explanation of how planets form. 1. Nebula. Planets are born from the remnants of a stellar nursery, a vast cloud of gas and dust called a nebula. Nebulas are primarily composed of hydrogen, helium, and trace amounts of heavier elements. 2. Protostar formation. Within a nebula, regions of higher density can trigger the gravitational collapse of gas and dust. This collapse leads to the formation of a protostar at the center of the collapsing cloud. The protostar begins to accumulate mass through the accretion of surrounding material. 3. Protoplanetary disk formation. As the protostar forms, a rotating disk of gas and dust called a protoplanetary disk forms around it. The disk consists of flattened layers where particles collide and stick together due to electrostatic forces and van der Waals interactions. 4. Accretion. Over time, the particles in the protoplanetary disk collide and merge, growing larger through a process called accretion. Small particles stick together to form pebbles, then planetesimals, kilometer-sized bodies, and eventually protoplanets, larger bodies several hundred kilometers in diameter. 5. Planetary migration. Some protoplanets experience orbital migration, where gravitational interactions with other protoplanets or the surrounding gas cause them to move inward or outward in the disk. This migration can significantly affect the final orbital configuration of planets. 6. Terrestrial planet formation. In the inner regions of the protoplanetary disk, where temperatures are higher, metallic and rocky materials condense and accumulate. These materials become the building blocks of terrestrial planets like Earth. Through collisions and accretion, larger planetesimals merge to form rocky planets. 7. Giant planet formation. In the outer regions of the protoplanetary disk, where temperatures are lower, volatile substances like water, ammonia, and methane condense into ice. The increased availability of solid material allows for the rapid formation of larger protoplanets, which eventually become the cores of gas giants like Jupiter and Saturn. These cores can then accrete massive gas envelopes from the surrounding disk. 8. Clearing of the disk. As planets continue to form and grow, they interact with the surrounding gas and dust. Eventually, they can clear out their orbital paths, sweeping up or scattering nearby material. This process leads to the dissipation of the protoplanetary disk, leaving behind fully formed planets. It's important to note that planetary formation is a complex and ongoing area of research, and there are still many aspects that scientists are working to understand fully. The above explanation provides a general overview of the current understanding of planetary formation based on scientific observations and theories.